Hello and welcome grade 12s to the optical phenomena task video. You can use this video to revise this section or to assess how well you have learned the work in the section. Red light of wavelength 700 nanometers is shone onto a photoelectric cell connected to a circuit. There is no current in the circuit. This situation is shown in this picture. Why is there no current in the circuit? Use the terms energy per photon, work function, threshold frequency, and photoelectric emission. Calculate A, the frequency of this light, and B, the amount of energy which each photon carries. You will need these two constants in these calculations: the speed of light in a vacuum and Planck's constant. What can you deduce about the value of this metal's work function? Question 1.4 is a true or false question. In each case, you need to say whether it is possible that current will flow in the circuit. A. Is it possible for an increase in the intensity of the red light to cause current to flow? B. Is it possible for an increase in the frequency of the light to cause current to flow? C. Is it possible that using a metal of lower work function may cause current to flow? Now a change is made to the circuit so that current does flow in the circuit. Remember that current strength is the rate of flow of charge. Explain why each of the following will cause an increase in current strength. An increase A in the light's frequency and an increase B in the light's intensity. Here are some terms which you could use as you answer question 1.6. Rate of photon emission, energy per photon, work function, kinetic energy, photoelectric emission, rate of flow of charge, or current strength. This table shows the threshold frequencies in hertz of three metals: sodium, cesium, and silver. Question 2 refers to this information. Of these three metals, which has the highest cutoff frequency, has the highest cutoff wavelength, has the highest work function, and holds its electrons the tightest? Calculate silver's work function. Calculate the maximum kinetic energy of the electrons emitted from silver by light of frequency 1,1 times 10 to the power 15 Hertz. Calculate the maximum speed of electrons emitted from silver by light of frequency 1,1 times 10 to the power 15 Hertz. You will need to use Planck's constant and the mass of one electron as you answer question 2. A solar-powered calculator has a photoelectric cell. When such a calculator turns on, we know photoelectric emission is occurring. You have a white light source of constant intensity and a red, green, and blue filter. You need to use this apparatus to investigate the question: how does light intensity affect whether or not photoelectric emission occurs or not? What will you do with the apparatus? What is the independent variable? And how will this be altered? What variables will you need to control for between the treatments? What will you measure or record? Describe the results which would support each of these hypotheses. An increase in light intensity increases the likelihood that photoelectric emission will occur. An increase in light intensity has no effect on the likelihood that photoelectric emission will occur. Which of the hypotheses given in 3.4 is correct? A, B, both A and B, neither A nor B. Thank you for joining us for this series. Grade 12s, if you had any problems with these questions, the answers are available in the series guide. Please also watch the other videos in the Optical Phenomena series for more help, or go to our website. Goodbye.